Okay guys, today we're doing 3.13, derivatives of inverse functions. Let's get started. Okay, first, let's see if you remember what inverse functions are, okay? There's only a few rules I need to give you about inverse functions because the test only really tests it in one way. So I'm going to teach you the way that the test tests it instead of going into real far in depth on inverse functions. Okay. So first thing is, let's say I start out with this function f of x equals x squared. Okay, well if you have that, that would mean that if you plug in 2, you would get 4, right? And if you plug in 3, you would get 3 squared is 9. Yeah? Okay, well, an inverse function, just to refresh your memory, is when you switch the x and the y. So right now you can think of this as being y equals x squared. You're going to switch the x and the y, so it'll be x equals y squared. And you just solve for y. So in this case, you square root both sides. And that's going to leave you with y equals square root of x. And this would be your inverse function. This right here is the inverse function. And the way that we usually denote that in mathematics is f to the negative 1 of x. That means inverse is equal to square root of x. So if you were to plug in 4, square root of 4 would be 2. And if you plugged in 9, the square root of 9 would be 3. Now, here's the key thing about these inverse functions that you're going to need. Look at what happened with the x and the y values. Here, the original was 2 and 4. Here, it was 4 and 2. Here, it was 3 and 9. Here, it was 9 and 3. So an inverse function switches x and y values. Okay, so let's just get an idea here. See if you understand. If I say the original function, f of 5 equals 9, then you would be able to say that the inverse, you're going to be able to give me 1 point. That's going to be the inverse of 9 is equal to 5. Yeah, this doesn't deal with this problem. I'm just making an example up. Okay, so an inverse function means you can switch the x and the y values. That's the first important thing you need to know about taking the derivative of inverse functions with the AP Cal 1 exam. Okay, so a very important rule to note with inverse functions is that the inverse of the original function is going to be equal to x. Okay, this is important because I'm going to show you the proof. Okay, and if you don't know what I'm talking about, let's just take that one I was just doing earlier. I said that f of x was equal to x squared, and I said that the inverse of x was equal to square root of x, right? Well, if you throw the inverse inside of the original, so if I throw this inside of the original, I would have square root of x squared. They would cancel each other out, leaving you with x. Okay? So if you throw the inverse inside of the original, all you're going to be left with is just x. So here's an example right here. This is the original, this is the inverse of that. Okay, so if I throw this inside of the x value here, square root x minus 4 squared plus 4, that is the inverse being stuffed inside of the original. That would cancel out the square and the square root, leaving me with x minus 4 plus 4. Those would cancel each other out, leaving me with x. Okay, this is important, okay? So let me show you the proof now. I'm going to use all the concepts we just spoke about. And instead of calling the inverse of f to the negative 1, I'm going to call it g, because that's how they do it on the exam, okay? This is how most books do it. Okay, so I'm going to call the inverse just g. Okay, I am going to say that if you plug g into f, you're going to get x. That's what we just spoke about, right? If you plug the inverse inside of f, you get x. Okay, so what I'm going to do here is I'm going to take the derivative of this left-hand side. If you notice, that's what we learned last lesson, this is chain rule. So, if you take the derivative, you take the derivative of the outside, which would be f prime, leave the inside alone, times the derivative of the inside. Okay, here, that's just saying we're taking the derivative of both sides. Here we go. Take the derivative of the outside, so we took the derivative of f, that's f prime, left the inside alone, still g, times the derivative of the inside, g prime, and the derivative of x is just 1. Okay, now if you notice, what I'm trying to do is I'm trying to show you how to take the derivative of an inverse function. Notice right here, I said this is the inverse, right? G is the inverse. If I can just solve for this, I have the derivative of an inverse function. So just divide by this thing right here. And your derivative of inverse functions is 1 over f prime of g of x. And that is, and here I think I even highlight it, yeah. That is how you take the derivative of an inverse function. So you're going to need to memorize this right here. Okay? And remember, g is the inverse function. So write it down or whatever, and let's try a couple examples here. Okay. Let f of x be a differentiable function. That means we can take the derivative of it. If f of 2 equals 5, f of 3 equals 2, f prime, that is a derivative, that is a prime. F prime of 3 equals negative 6, and f prime of 2 equals 3. The function g is differentiable, and g is the inverse of f. They're doing the exact same thing I was doing earlier. G is the inverse of f. What is the value of g prime of 2? That is saying to take the derivative of the inverse, and then plug in 2. Okay, let's get a pen here. Remember, if g is the inverse of f, this is what you should do right at the bat. Then I know what g of 5 is. It's 2. Because remember, you can flip-flop the x and the y values on an inverse. I know what g of 2 is. It's 3. Now, you cannot do that for the slopes. The slopes are not the same. That doesn't work like that. Okay? That's what we're trying to find, is the slope at 2. Okay, so remember that function that we just figured out. G prime of x is equal to 1 over f prime of g of x. And we're trying to do this at 2, right? So let's write it out. G prime of 2 equals 1 over f prime of g of 2. Okay, let's work it out. G of 2, that's the first thing we need to figure out. Well, if you wrote this stuff over here because it's an inverse, then you know that g of 2 is 3. So we got 1 over f prime of 3. Well, f prime of 3 was given to me. F prime of 3 is negative 6. Look at that. That's the derivative of the inverse at 2. It's going to be 1 over negative 6. So let's do another one. Find the value at g prime of 5. Okay, same thing. G prime of 5, 1 over f prime of g of 5. And that is a prime if you can't see it. Okay, 1 over f prime of, what is g of 5? Well, if you come up here, we figured out that g of 5 was 2. Yeah? So, put a 2 right there. 1 over f prime of 2. F prime of 2 is given to me as well. It's going to be 3. 1 over 3. That's the slope of the inverse at 5. It's 1/3. The whole thing about doing these is noticing that it's inverse, that they want you to take the derivative of the inverse, and remembering that you can flip-flop your values, your x and your y's. Okay, that is the whole key to doing this. And that's the lesson.